Hey there, I wanted to go over Dr. Raviv's practice test, hopefully fill in some of the blanks on any of the questions that you guys have. So on these first two, what he's doing is he's going to be using KVL, which states that if you add up all the voltages, it should be equal to 0. And so you can start wherever you want. Typically, he starts on the left side over here with this 24. You could go from any of these points as long as you go in a circle. So let's draw that circle there. And remember, look at this number here, this 24, it's going from a negative to a positive. So if it goes from a negative to a positive, it's going to be a negative number. If it goes from a positive to a negative, it's going to be a positive number. So at this 24 volts, it's going from negative to positive. So it's going to be a minus 24 plus 4 volts, this 4 here, plus 8 plus, oops, sorry, got ahead of myself. And then this Vx right here, it goes from a negative to a positive. So that's also going to be a negative Vx plus 18 minus 12 plus 6 equal to 0. If you solve that, then Vx is going to give you 12 volts. He does the exact same thing here. He starts at this 9 plus to minus, so it's plus 9 plus 12 minus 24 plus Vx plus 16 minus 12, and goes in a circle there, and he solves it, which gives us negative 1. Moving on, let's erase this here. Okay, so the way that these problems work is that a little formula is y2 minus y1 over x2 minus x1. So first, I usually start out by writing my ranges. So we have 3 distinct ranges here, from 0 to 4, from 4 to 6, and from 8 to 12 already. And so, oops, okay, perfect. And so from the 0 to 4, we're going to be doing, let me write this. So it's y2, so let's say it starts at 10 minus 0 over the time 4 minus 0, and that gives us 2.5. And then for this middle one here, it's at 0. So this is going to be 0. I mean, you could also look at it and be like a 0 minus 0, a 0 minus 0. And then this 8 to 12 range, it's going to be 0 minus 10 over 12 minus 8. And that gives us negative 2.5. Okie doke. And then you use this info and you graph it. So here we have 2.5 at 0 to 4, 0 at 4 to 6, and negative 2.5 at 8 to 12. And that is why we graph this here. It's at 0 here and negative 2.5. So, he's trying to say here that this is 2.5, and this point here is negative 2.5. Alrighty, and then so the current is equal to power over voltage. Power over voltage. And our voltage is given to us here at 20 volts. So we say 2.5 over 20, and that's how we get this 0.125 from 0 to 4. And then from 4 to 8, we do the same thing. 0 over 20 gives us 0. For this last one, it is negative 2.5, our power, over voltage, which gives us negative 0.125. And then we can go ahead and graph that. So if this is 125, if this is negative 125, then we would draw it. Find the power absorbed or supplied by element number 1 here. Alrighty, so power is equal to IV, and looking through here, we can see that power is equal to 4 volts, so I times 4, and the current coming through here is 4Ix, so we can replace the current as this. Alrighty, so we can say that 16 times Ix. And now what is Ix? Well, a way that we can find how much current is flowing through this element is by doing nodal analysis. Let's take this node, and so, let me erase that. And so looking at this branch here, coming through it is negative 4Ix. Ix. Looking down here, going away from it is 4. At this branch, going away from it is also 4, equal to 0. So negative 4Ix plus 8 equals 0. Ix is equal to 2. And then we can plug this back in here. 16 times 2 equals 32 watts. And that is 32 right there. Calculate the power absorbed by element 3, which is here. So we can pick either this node or this node to find how much power is flowing through that branch right there. The professor uses this one down here, so we can explain that. I can do both actually. So let's look, flowing through this branch, going away from it is 4. Coming into it is 6. And then, because of this 6 right here, 4 and 6. And then flowing into it is Ix. This branch here flowing out is 4, set that equal to 0. And then here we have 8 minus 6 minus Ix equal 0, and this is going to be 2 minus Ix equals 0, and Ix equals 2. So we can also show this through this node here. So looking at this branch, we have 4 amps here. So 4 amps going out of it. Here we have coming into it is minus 2. This down here is plus Ix. Flowing the opposite direction here is 4. Set that equal to 0, and then we would have these two cancel out. Negative 2 plus Ix equals 0. Ix equals 2. Those are two different ways of solving how much current is flowing through it. And then, so to find the actual power absorbed by it, similar to this one up here that we just did, so power is equal to VI. Power equals volts. The amount of volts is 6. And now we found the current, so that's 2, which equals 12 watts. Finding Ix, so we can simply do nodal analysis here. So looking at this branch, flowing out of it is this 2Ix. Coming into it is 4. Flowing out of it is 12. Looking at this branch, minus Ix. And coming straight into it is this 3Ix. You set that equal to 0. And then, so this would be minus 2 Ix plus 8 equals 0, and then Ix be equal to 4. MA. Alright, so find I1 and I2. Okay, so no problem. Let's look at this node here. Flowing into it is I1 minus I1. This node here is 4. flowing out 8 is equal to 0, and that is how we end up with 12. Nodal analysis here. Coming into it is 8, out 2, plus I2 is equal to 0, and I2 is equal to 6. Find I1, which is here. It says find IX first. Let's just do nodal analysis here and see what happens. So flowing into it is going to be a -4, and then this branch here going out of it is 2IX. Then on the right hand side we have plus I1 is equal to 0. Okay, and then IX. So let's solve for that by looking here. And we can do flowing into it is -IX, out of it is +4. This branch here is going to be +2. This is IX is equal to 6 MA. So plugging it back up here, so -4 plus 2 times 6 plus I1 equals 0, and this would give us I1 equals -8 MA. Oh, these are my favorite, honestly, because they're just so much fun and so simple. Okay, so when you have something like this, when they are diagonal from each other, or when they are parallel to each other, then you can always do something like that. And if two resistors are next to each other, you can simply add them up. Okay, so starting with this 3 and these 6, they are a triangle here. Oops, that's a really terrible triangle. So for a triangle or parallel, you're going to do 3 times 6 over 3 plus 6, and this is what he means by this parallel symbol there, and so that is going to equal to 2. So we can redraw this whole branch as, sorry, I am a terrible drawer. Alright, so let's pretend that this is our thing. You know what, no, let's not pretend that. That's a terrible drawing. Terrible, Holly. Alright, so now we have a 2, and then so 2 plus 2 is going to equal 4. So now we can redraw this whole thing here as 4, and now these are parallel, so we can do 4, which is equal to 4 times 4, 4 plus 4, which equals 2. So now we can do 2 plus 1, which equals 3. And same exact thing here, so we do 2 plus 2, which equals 4. This is 4, and then we do 4 times 4, 4 plus 4 here, which equals 2. So this gets changed to 2. 2 plus 2 right here equals to 4. And then 4 parallel 12 equals 3. 3 plus 9 is equal to 12. Find the value of V2 such that V1 is equal to 0. So we can kind of split this in half. And volts equals RI. So going like this, we have volts equals to 20I plus V2, which equals to 0. So this is our first equation over here. And now we need to find I. We know that I is equal to V over R. And so what is our voltage? It is over here, 20 over 10, which is the current that is flowing into this V1 here. 10 is the resistance, and so that equals 2 amps. And so we can say that, plugging it in here, 20 times 2 plus V2 is equal to 0. V2 is equal to negative 40 volts. So, alrighty, so this is KCL, adding up all of the currents, making sure they're equal to 0. So he has 3 different loops here. He named them I1, I2, I3. So going from a negative to a positive gives us a negative, a positive to a negative gives us positive. So this is why he started at negative 3 and then plus 6K, because resistors are positive the way that we're doing it. And then jumping down, we need to, because voltage is equal to Ri, we have the resistance, so voltage is equal to 6I. Okay, so negative 3 volts plus 6I, you can say I1 as he says it, and then plus this 12 resistor, and then we have the I, but it's going to be, we're doing it from this first part here, so I like to say that's why we put it first, I1, and then minus whatever this is over here, so this is minus I2 equal to 0. And then looking at this second one, we take it from this 12 volts here, so this is 12, and it's sharing a branch with I, so we say 12 I2 minus I1, and this is where it's where we're starting from, minus shared, if that makes any sense at all. And alright, so we have this 12 I2 because that's where it's starting, and then minus where it's shared with, which is I1, and then we travel up to the 6, negative to positive, negative 6, and then down here we have another shared resistor here, so we do 6 with where it started, which is I2, minus where it's shared with, which is I3, and set that equal to 0, and that's how we got this second equation. This third equation, we do the same thing. We start over here and we see that this resistor is shared. We do, he actually started over here. We do 6 times where it started, which is I3, minus what it's shared with, I2, is equal to 0. And then going up to this 12 here, we do 12 I3, and then minus 3 volts. Alright, and we have one more equation because we have a current source coming through here, and I always like to think from the left to the right, and so it's I2 minus I3. This second one down here, it is the exact same thing. So for I1, we start with 2I1, and it's not being shared with anything, so that's fine. Then we go to 8, and we have 8I1 minus, 8, and then where it started, minus what it shared with, I2, plus this 2k here, and it's starting with I1 minus what it's shared with, which is I3. Set that equal to 0. And we do that for the rest of the 3 boxes. And there's no other external, like current source here that we see that we need to write down an extra equation